I was thinking this morning, I don't know that FAST has ever had a panel discussion before, so we're going to try something new here. Hopefully it'll be fun. The topic is storage systems in the LLM era. I'm thinking more storage systems and AI in general. There's a lot of potential meat there. And I guess we should start by introducing the panel. I can, a few names, but maybe if you just go start with Glenn and work over to Nisha and each tell us who you are and something about your experience with AI and storage, since that's the intersection of things we're going to be talking about.
All right. Hi, everyone. I'm Glenn Lockwood. I work at Microsoft. I am a fallen storage person, so I spent most of my career doing storage architecture for HPC, and I came to Microsoft and did storage product for AI, and now, as of 2 months ago, I am no longer in storage. I am 100% AI, and so I work with our biggest AI customers to solve their infrastructure problems.
Hi, I'm Dean Hildebrand. I spent a little over a decade longer in HPC working on scalable storage systems and primarily at IBM Research. And just as I was leaving there 7 years ago, I had this idea that I wanted to trace I/O workloads on a GPU, but I couldn't get funding for one GPU. So anyways, then when I joined Google, I'm in the CTO's office, and I work on our overall cloud storage strategy. If there's a file storage offering, I probably have touched it in one way or the other. And now, as you can imagine, in the last year, there's been a lot of hubbub across the entire portfolio around, like, what do we do to solve this AI problem? Do we need something new? Or do we have is good? And it's really interesting when you bring in a full platform view to this and not just every individual storage system. So glad to be here.
I'm Greg Ganger. I'm at Carnegie Mellon University. I guess on the storage side, I've been involved in FAST since it started. And I don't know, I think I've come to every one of them. And on the AI ML side, 10, 12 years ago, before everybody was paying attention to it, some of the ML people at CMU, which actually has a machine learning department, came in and started asking us, can you help us figure out how to parallelize and how to create, parallelization models that make sense for this weird type of computation that's statistical in nature rather than precise in nature the way most parallelization focuses on it. And we've kept working with them on further and further explorations in that sort of space. And so I guess I have an academic viewpoint on the systems for ML side of things.
Hello, my name is Zhang. I'm responsible for the Ray open source project at AnyScale. As an introduction, Ray is a distributed computing framework that's commonly used for AI workloads. For example, OpenAI uses Ray as one layer in their stack to train all their largest models. So it's fair to say that in the past 3.5 years, I've mostly been working on AI. Before that, I spent 10+ years mostly working on storage, starting from the Oak Ridge National Lab, working on HPC, the Laster file system, if you guys know it. After that, Hadoop, HDFS. So I think I have some viewpoints from both angles.
Hi, everyone. I'm Nisha. I started out in the storage world, mostly in distributed storage, and did a whole bunch of different things, distributed storage, file systems, worked with Keith for a while. And the last projects that I did in storage were in flash and persistent memory. About 9 years ago, I switched over to AI. I built an AI company that built the first machine learning operations platform. So one of the weirdest things is I actually wrote the first Wikipedia MLOps page. And I could not get Wikipedia to accept it because they said, it's not a thing, you just made that up. And it's going to be a thing. So that company, got acquired a while back. Now I run a company called Pyxeda. We commonly go by the name AI Club. We do AI literacy and AI education. So in that front, I do a lot of multidisciplinary work in the application of AI in everything from satellite imagery to genetics. And also kind of like scalable platforms for launching AI education at mass scale. Right now, I'm trying to launch 100 schools in Asia, all running on the cloud, all doing stuff. So that's kind of like where my world of AI and my world of storage meet.
Okay, thank you. So the way I was thinking of framing this is mostly I'm just going to throw up some topics and questions and invite the panelists to raise their hands or offer comments. And respond to each other, and we'll move on topic to topic, and at some point have some questions from the floor. And the framing I was thinking of is, we're all here at FAST. We probably all want to come to future FAST conferences. So what should we be thinking about in terms of storage and AI and machine learning and large language models that might be relevant to our future career as FAST attendees? So sort of my model is imagine FAST in 6 years. 2030 is a nice round number. So what kinds of topics are going to be hot at that point in time in the future at a conference that has this intersection? And I can imagine a lot of different directions, but I know enough about storage, but less about AI than all the people here. Something's rumbling around us here. So some of the obvious wake up computer. So I just sort of had this idea that what I asked in the method of every AI conference or every AI conversation these days, I started by asking ChatGPT some questions and basically asked it to propose some titles for a future FAST conference. And so I've got some rough sessions. So one is what does AI need from storage? So a session about storage for AI. What would be, ChatGPT has some ideas, and a couple of these paper topics came from our panel too, so you can have a quiz later, which papers are human and which are ChatGPT. So I'm curious, does AI need something from storage other than just lots and fast or slow, or are there special needs, or is this not a workload that we need to do something new and different for?
So I guess I'll start with the inflammatory statement that AI large language model training does not have storage problems. Just keep making it cheaper and bigger and get out of the way. And that's what my customers have consistently told me about how they view storage.
How far out of the way? Do you want a file system? Do you want objects? Do you just want the raw bits on a disk?
Doesn't matter. They can figure out how to make best use of it. Just tell them what the parameters are and they will make it work. They don't want to think anymore about storage or have to learn something proprietary. Just let them deal with it and they'll take care of it.
Maybe I'll add then, I don't think I necessarily disagree with that, but I'll say that if I expand it out to a larger set, we have multiple different types of accelerators. We have multiple different types of software environments like GKE, Kubernetes, and just regular Linux with Slurm and other schedulers. And then in addition to that, we also have like a wide variety of customers, right? And some of them are on that side, like you said, right? Like they hired all the best people and they know exactly what to do. And then there's all the other way to the other side where they're like, look, I just want a YAML file and I want automatic data tiering, ingestion, training, checkpointing, and restart. I want all of that just to happen from like a single YAML file, please. Why do I have to worry about where the storage is? And so, I think that like we have a lot of the nuts and bolts, but when you like deploy a supercomputer and then try to point it at the existing storage systems, things fall apart and there's challenges. And so I think that's kind of where we are at the moment, right? Is really trying to adapt and bring up both sides of the coin and adapt to that wide variety of like, it's not just a single supercomputer. It is many supercomputers in many different forms and trying to handle all of it.
So one thing I think I would generally agree with, both of the comments. Perhaps the key may not be in the data path. The data path, I think, faster, cheaper, as much of it as possible. But the control path for AI, the problem is that AI relies on data, and there are so many laws coming out now that we have absolutely no idea what data we're using and why did the thing we did. And there's going to be a very unpleasant, tracking problem that is going to emerge. So one of the simplest ways I can describe it is AI generates data now. Unless you're really, really careful, you can't tell the real data from the stuff that the AI made up. So, at the moment of creation, but afterwards you don't know. So the control path and the ability to just keep track of it all from a logical standpoint and how it links to everything, there's a problem there.
That's a great segue to the next session at this hypothetical conference about data management for AI.
You can let him get away with that.
Can you elaborate on sort of what the... That was very high level. So what's a research topic that somebody?
Roll back for a second.
Oh, okay, sorry.
I think echoing the point that the current large model training doesn't have a data problem, I just want to make it more concrete. And one kind of interactive kind of small quiz. So how large do you think is the size of the entire Wikipedia, like English content? I have three options. If you think it's over 100 gigabytes, raise your hand first. And second tier is from 20 to 100. And third tier is below 20 gigabytes.
Compressed or uncompressed?
And ASCII or tokens?
No, the size, the gigabyte size, uncompressed.
And ASCII.
So the first option, over 100 gigabytes. Nobody? Okay, between 20 and 100. And below 20? I think, yes, right on the border of 20, yeah. So basically, so every single computer can load it, right? So even the entire internet crawl is like a couple of terabytes. But I think things will change a lot with multimodality. And recently, there's a new concept called large world models. So I think we will be witnessing this very interesting change. So it's hard to predict, but let's see. I'm personally very excited.
Yeah, I just want to echo the point about multimodality. One of the most interesting things that has happened with AI in the last year or two is that previously AI used to be very unimodal in the sense type of modality, there's an AI for that. Now the AIs that we have now just intersperse and go from modality to modality without blinking. That's going to dramatically increase the amount of AI data that it can handle.
Could you elaborate on which modes you think are going to contribute most to the unknown, these future storage problems?
So one example could be, for example, that the James Webb Telescope is generating, I believe I checked, 235 gigabytes of data a day. And that is inherently multimodal because it captures data on so many frequencies, not just the visual spectrum. And we truly don't know how to analyze it at the moment. So there's going to be lots of AIs that do cross-spectrum, compare all sorts of things. So huge.
Yeah, I was just going to add to that in the sense of, you have one type of storage system for where it lands in the source of truth, and then you have a training storage system in terms of how that, and then you have a feature store that analyzes that storage system, and then you have, let's say you want to now broadcast out the results of whatever you built out into a CDN and in other aspects, right? And then the data management aspect of what you're saying as well. I just wanted to amplify that as that's starting to get really something. And when you have four, I would say on average, 4 different storage systems being used throughout the process, it starts to get pretty tricky in terms of now going back in time to say, what data built that model across these systems? And so, yeah, it's just data management is
So
another example, maybe if I could add, is just, so don't go out into space, just think about the human body. Multimodal in the human body is, your genome is one, your phenotype information, right? Your x-rays, your blood tests, there's so much data and they're all different modalities, but they all belong to you. And so you've got an interesting data management problem because your privacy has to be measured across all of them, but they also have to somehow be merged into the single AI that's going to try to understand how to cure your cancer and nobody else's. So
you were touching on sort of the keeping track of which models generated which data problem. And so 10, 12 years ago, we saw a bunch of papers at FAST about data provenance. Is that something we should be revisiting or thinking more about? Or
we should never have stopped. But going back to what you were saying and making sure it doesn't get missed, right? Right now, the bandwidth, the speeds and feeds for LLM training, for example, it's noise compared to the work of training the model itself, right? But if you start going to data sets and trying to use them that historically were viewed as cold data that you didn't have to worry about. Say you wanted to take a bunch of the videos at Google and a bunch of the YouTube videos stored and start training models against all of those. All of a sudden, stuff that used to be cold, right, that you relied on being cold, and you designed your storage system around having some bulk of the data that gets touched very rarely starts getting churned through suddenly, right? Now we're going to have to design storage systems very, very differently to accommodate that sort of thing, right? And that's assuming that you could keep up with feeds that require going through data that becomes 100 times more voluminous than the kind of data that's being used to feed now, right?
So I feel like that's a bit of a myth that's perpetuated by the storage industry, that suddenly AI needs access to all your data all the time. And in practice, that's not how LLMs are trained. I mean, you don't take raw text, you don't take raw images and just shove them in a GPU and train. I mean, there's an extensive pre-processing pipeline that has to happen. And if the amount of data that you pre-process is too large to manage in your hot path of your training loop, you find a better way to represent it. That's what tokens are. I mean, no one takes ASCII files and puts them in a GPU. And so that pre-processing step is happening offline, is happening before training ever begins. And from my perspective, that's just a standard big data analytics, Hadoop style problem. What's new about that?
Yeah, but I am seeing people want more real-time access to real-time information, right? And so I think over time, thinking about 2030, they're going to want to be able to train smaller amounts and improve those models dynamically, which I think is going to get us to a much less, we don't have a week to fine-tune our data into the right format and get the right columns in the right spot. I think it's going to happen that way. But then in addition, I know when we started this, we were like, inference, there's no storage there. It's a command prompt. Until people start showing up with petabytes of satellite data and genomic data and other aspects, and they're like, well, one, I want to load, my model onto 1,000 nodes simultaneously, and then I want to process this amount, and I want to do, and how fast can you do it? Because actually the answer is time sensitive to me. And so I think where we are, yes, but where we are evolving, I think it's going to start getting we don't have time to take every piece of data and remunge it into a new form. We might not have time.
I mean, it has to happen somewhere though, right?
Or we could just make it efficient from day one, right?
And so are these actually new storage problems, or is this, as Glenn hypothesized?
Talking about the new storage problem, I think another very interesting emerging type of storage is embedding plus vector database.
Yes.
Yeah, so for example, if it's not only a kind of string in, string out query problem, but you need to kind of complement that with retrieving your own data. It's called RAG, right? So retrieval augmented generation. So that industry is growing really fast, and I think we're still not seeing the kind of peak of it.
Yeah.
And you're definitely right that you can, I don't want to use the word downsampling, this is the wrong word, but you can take data that would have been too voluminous and bake it down into something that you can then work with. But as the original data gets larger, the potential consequence in what you're losing when you do that gets larger, and it becomes a trade-off. Is it better to say we're going to try to find a way to reduce the amount of reduction that we have to do before we can make forward progress, or do we increase the amount of reduction in order to avoid having to do that, right? Yeah, and I don't know what the answer is there. Yeah,
well,
maybe you already do, but it feels like that's going to be a green space there. There's going to be a lot of trial and error that happens.
So is that a storage problem, or is this sort of, Glenn also hypothesized it's bigger and faster and cheaper, and that's what we already care about in storage. So it's not a new problem for us. I don't know if I'm misrepresenting you, but
I would argue that, for example, say you want to train on a bunch of 4K images. What's the point of training on 4K movies with 32-bit color channels when all that stuff is being reduced down to 4-bit ints for training or inference? I mean, you're training a model. You're not doing rocket science. You don't need FP64. So you're doing a bunch of really dumb approximations. I mean, anyone who's used any kind of AI chatbot knows that these things are impressive until you actually start trying to use them for useful things, and then you realize they're kind of dumb. And so that will undoubtedly change, but do we really need full fidelity of in this massive data problem to be solved to get the next generation of generative cat videos?
So Glenn, to this point and the earlier point you made that there's a big data Hadoop style processing before training, I think one interesting question is, do we kind of push down these kind of things to the storage system, or we consider that kind of pipeline separate? So concretely, from our users, one very common demand is deduplication of the web crawl data, for example. right? And like you said, there's also a strong need to retrieve data with certain condition not accurate.
And
Go ahead. I was going to suggest we could try another topic.
Here, I'll just end on one end, then on that one is like, I think there's like a weird amount of inefficiency in the system that we're very comfortable with today. And we're copying data all over the place. Like we're downsampling or whatever, munging, taking 4K down to like 128 kilobyte images, and like we're doing a lot of work, but it's incredibly inefficient. The amount of, if you think about it as write or read amplification in a single byte of data that we're trying to work with is just amazing. And so I do think there's a big opportunity in that space over time to get a lot more efficient in terms of how we're just handling this. It works today, but is that the bar, right? Like, I think we have a higher bar.
So another area that maybe think about is, we always think kind of bigger, right? There is a lot of value in the land of AI in being smaller. So if you can build storage devices or have storage software that can work in tiny devices, companion with the AIs that are learning how to work in tiny devices, because the energy footprint is insane, and anything to reduce the energy footprint is a very big deal right now. So that's another way to look at it. It doesn't have to be bigger. There's merit in being really small.
So I think the other side of the coin for a conference like FAST is we've talked about sort of what does AI need from storage. I think the other side is if you're building and designing storage systems, how can storage systems and storage systems researchers use AI in the future to, and ChatGPT seems to have done a match arbitrary storage problems by putting AI in the title someplace. So, find bottlenecks using AI, data placement using AI, root cause problems using AI.
I think I've reviewed some of these papers.
Wait a second, one of those is mine. I think it's also stealing, I'm just saying.
I'm so glad I didn't have to be the one that did the crotchety old person saying, there's nothing new under the sun, right? Like, I don't know, how many people in the room remember the term autonomic computing? Right? So you can see, you count the gray hair, right?
Hey, wait a second.
Self-tuning, self-healing, self-this, self-that, right? Like everybody that's over a certain age worked on a project that had to have one of those adjectives in the name because that was how you got attention in the period from sort of 2000 to 2006 or 7 or something like that, right? And then it all kind of went away because, frankly, the ML wasn't good enough. Like, you can't automate decisions based on a predictive model if the predictive model keeps getting it wrong at too high a frequency and too large a gap from the prediction to the reality, right? And, I don't mind seeing titles that look similar because maybe it's good enough, or it's reaching the point of being good enough that some of these things that were tried in nascent stages, and I'm not saying that it's, it won't be new when it's tried, because it'll end up being done differently, and the problems are different now, right? That we care about using these things for. But, it's exciting to see that maybe, just like it's shocking how well it's done in some other domains, maybe it's going to be pleasantly shocking how well it can do with some of the things that we aspired to use some of these automation tools for a while ago can actually work out this time. So you did, I'm sure. We probably, people in this room probably submitted papers with titles that were, one step away verbiage-wise from these, right?
Yeah, we actually got ours published 3 years ago.
You're looking for it. But 3 years ago doesn't count. That's in the current era, basically, right? Yeah. So, but the paper from 2004 with a title that's similar to these, right? That's the one where you look back and you go, wait a minute, how come, right? Yeah.
So there's, thinking about a storage system, there are umpteen policy decisions in it. What do I prefetch? What do I evict? How do I decide when to tier my data? In a distributed system, how do I decide where to place my data? Et cetera, et cetera, et cetera. Should researchers just do the random, let's take an idea in an AI and collide it and see if something wins? Are there techniques? What would be the filter to say this would be a good problem in storage to try to apply a AI model to?
Well, I generally think that if a problem has kind of like these two characteristics, it's good. Do you have data about it? As in, you know what good looks like, because otherwise, and then the next one is, do you know how to measure and figure out if the AI did better? Because you can always apply AI to a problem. That doesn't mean it's going to do better, but sometimes you can't even tell.
Yeah, right. And
If you have those two, then yeah, give it a shot. You know?
Yeah, but I put one in there about IO path. I don't know how many people have looked at critical section IO paths of storage systems, but they tend to be a bit wonky in terms of maybe they're a few thousand lines longer than they should be inside of regular single function, and they have a lot of optimizations there around bits and caches and all the different aspects. And I'm really hoping that AI, if anything, it can either take existing code and optimize it, or we don't have to sit there and cache line align a variety of different aspects of the system. So I think there is some grunt work as well that maybe they can help with, and we can just make better file systems or storage systems from day one, as opposed to having to tune it over the course of a decade.
Or alternatively, keep making horribly complicated file systems, but use AI to make them accessible to people. I used to work in the DOE lab system, and I would get tickets saying, my I/O is slow, what's going on? You don't need a highly paid PhD to answer that question. It's just basic troubleshooting steps. So why not throw an enlightened chatbot at it and help that person get better, quicker use out of their complicated file system, rather than have to wait for days for that one person on staff to know how it works.
That is, create automated tools to train people to use it.
Yeah, just lower the barrier. You don't have to be able to read cryptic kernel code in order to understand why some weird behavior is manifesting when you run your application a certain way. I mean, it's not a satisfying thing from an I/O or storage research standpoint. I mean, storage research should make the storage better, but in the absence of better storage, make it easier for people to break through that barrier.
Yeah, no, and
Make better users.
Yeah, it's a dream, right?
Yeah, no, and there's a whole body of research and different tools and techniques to spot bugs or spot performance problems that are less AI-based, but yeah, it's definitely a real problem.
Yeah, I just have one more detailed point to add. I think it's important to think about which of these problems are more relevant to the recent AI improvements versus can be solved by the previous traditional machine learning. Basically, we need to think about in which problem the input data is text or unstructured. I think in some of the problems, the input data is structured like events. Then you can do it with deep learning whatsoever, right? Then we shouldn't expect a lot of improvement with the recent AI. But if it's logs and error messages or source code, then we can expect some big jumps.
So another thing that I think I'm starting to see more in the product world, which both says it might happen, but it may not be for research, is essentially conversational interfaces to complex systems. So you can call up your storage system and say, hey, storage system, how are you doing today? It wasn't too bad. I had a lot of I/O last night. I've got a bad disk over here, slightly overworked CPU over there, kind of stuff. And this is real, and this will show up in product in the next 2 to 3 years.
I have an itch on server 3.
Basically, I've got an itch on server 3, exactly. Because that's the kind of world we're moving to.
Right, and that's, and ChatGPT helpfully provided some titles around using natural language for managing your AI system, your storage systems.
I want to not lose, for all the students in the audience, I think one of the things you said that I want to make sure that we end on or amplify it. Before you tackle a problem saying, I'm going to apply AI to this or ML to this or whatever to make it better, start by figuring out what good looks like and what the gap is to figure out whether or not after you did the work that you did, even if it was perfect, it was worth doing, right? It also gives you a thing to train for, right? It gives you if you're doing supervised learning, it gives you the thing that says what good looks like, right? So it serves two purposes, but it serves the filter the decision-making process on whether or not you're going to go down that path as well, right?
I do remember my advisor saying, RAID 0 is sometimes hard to beat. And so, before you come up with a new striping algorithm, maybe consider on whether or not your current one is fine.
Yeah. There's a running joke in the AI world that first you get the simple machine learning decision tree to work, then you spend 6 months getting your deep learning to work so that you can publish. Because the second one is highly temperamental, but the first one is not publishable.
So I'm perhaps somewhat naive about how these natural language systems work, but when I think about using natural language to configure a system or to query my data, natural language is inherently ambiguous, right? That's part of the expressiveness and the poetry of the way we talk to each other. And computers we've traditionally interacted with in very unambiguous, very clear languages. And so is there a problem having these two worlds meet? If I can start using my language to query my data, do I not know what I'm getting because maybe the machine heard something different than I intended, just like I could say something ambiguous and you could misunderstand me?
Yes.
And so there's not a silver bullet here, you're telling me.
I guess maybe the more important, it's a very important point, and one of the things it implies for the previous point of what good looks like, it's really hard to measure. Previously, when we knew what the right answer was, we knew whether or not we got it, and we could compute error, right? Answer was 0.5, we got 0.538, we know what the error is. Here, we've got one sentence it could have said, one sentence we might like, and we have no idea what the right answer was. And everybody's got a different opinion. So one thing to maybe watch is that there's a body of research coming out on just how to measure LLMs. And that's a very, very nascent field, but if you're going to build an LLM to solve a problem, probably need to figure out what is the state of the art in measuring the thing so that you can use it.
And yeah, it's not clear that humans are great with the programming languages either. I work at a database company, and we do get customer issues on a routine basis where I ran this query and got this result, and it seems wrong to me. It's like, well, you don't understand some of the language in the query you wrote, so this world may not be any worse. And I don't know what I have next here.
But we didn't do the last one.
Hmm?
I mean, we don't have to, but.
Yeah, no, is there something interesting here you wanted to call out? Or?
Not necessarily, but not necessarily interesting. So something about systems that tune themselves to goals that are specified is the biggest challenge in that whole process is eliciting the goals.
Oh, yeah.
And so one of the things that we're going to have to work on or think about if we're going to get back into this space is how we're going to do that sort of thing, right? A part of why automation tools didn't take when we tried to do this stuff a while ago is people were very uncomfortable with them and not knowing what they were doing, but they were also not comfortable with only being able to say, I need this performance for whatever, or I need this reliability, and then not knowing what the heck's gonna happen based on it, right? And when I say people, I mean the people who are going to get blamed when it doesn't work, because those are the ones that are close to it that are going to be the people that are supposed to be able to specify this stuff. And so coming up with analogies to how they do their work and figuring out how to incorporate that into the design of systems that are supposed to automate themselves becomes useful, right?
Yeah.
Like operators of storage systems or of systems in general discover that it's not good enough, not because somebody had a pre-specified level that they were supposed to hit, but because somebody comes and complains it's not good enough, right? Which can give you the one end of the spectrum. And then what happens when you're overshooting becomes harder to figure out how to elicit, because the obvious way to do that is to go slower until somebody complains. But when they complain, you get in trouble, and that's a place you don't want to be, right? And so figuring out how we're going to do that is an interesting.
Yeah, no, and anyone who's worked with real-world customers knows that they can be extremely unclear about what their goals are from whatever it is that you're selling them.
But they know when it hasn't been met.
No,
so one thing people are good at is complaining. So it has to be part of how we elicit things, but it can't be the only answer.
Or can you is there a way to observe what the customer is actually doing and figure out what their goals are if you're smart enough?
So one thing that might be worth looking at. So one of the reasons ChatGPT works the way that it does is it employs something called RLHF, which is reinforcement learning with human feedback. There are armies of humans all over the world reviewing all of its answers and saying, I like that one. So that's the cycle that the industry has developed to incorporate human knowledge. How well it works, time will tell, but that is what they're doing.
So complementing the language side of it, we need cameras. So you can tell whether the person is smiling or frowning, right?
I'm sure the security people will love
Oh,
that.
yeah.
Oh, yes.
as they love almost all of the AI stuff, right?
Yeah.
The data collection for it.
So it can automatically turn on my laptop camera, is what you're saying? Yeah.
And send it to Google,
Yeah,
to
yeah,
Microsoft,
sure.
yeah. I think the key here is, you don't want to go full automation. I don't really see a future where complex tasks are fully automated by a black box LLM or AI. I mean, putting my Microsoft hat on, we do copilots, and it's deliberately a copilot because you are not supposed to blindly trust it. It's not a pilot. It's going to screw things up. And so this just helps you get a little closer. And so, language is imprecise, and so the results you get are going to be imprecise. And people are going to say it's not good enough, and you can say, well, that's ultimately on me as a human, and I got help from this thing, but, it's, I think the issue of, fully automating all of this, like, look at any automatic, transparent attempt to make anything better, like caches, for example. Caches are great in CPUs unless you're doing HPC, in which case you need to actually know what your cache sizes are so you can tile your data accesses so it fits exactly in this hidden footprint that gets cache aligned and fits exactly in your L2 cache, right? And so automation is great until you really need to get something perfectly right. And you, I think, will always need a human to do that.
Yeah.
I was also going to just add, telemetry is hard. And so it can't monitor and it can't say anything about what's going on in the system and be smarter about it unless it has all the data, right? But it just takes years that I'm seeing to write telemetry to very sophisticated distributed systems to know exactly what's happening on all the clients and in the storage servers and on the back ends. And by the time you get that one right, we've slotted out a new storage system underneath or something else to that effect, right? And now, all right, let's keep it running. And just the amount of, in cloud side, the amount of telemetry, control plane work that has to go on in order to get this thing running 24/7 is just mind-boggling. And so anyways, I just sort of say that to say it's one thing to say it could be doing it, but does it have that data, and are we willing to invest the amount of time and energy it takes to provide the telemetry that it would need to be smart enough? I don't know. Time will tell, right? People tend to stop somewhere and say good enough. I don't want to pay any more.
So just to add to that, it's absolutely true. One of the things that maybe it might present an opportunity for research is one of the things that AI has shown itself to be quite good at is something called transfer learning, where it can learn from one environment and apply it to another. If that can be applied to, for example, learning from one storage system and applying it to another, that would be very cool and very practically interesting as well.
There's been a lot of success with that in
Yes.
the auto-config type setup.
That would be amazing.
Learning from one set of customers and applying to another set of customers. Yeah,
It's worked out well in all sorts of areas of medicine, climate, everything.
So I guess the other sort of broad area I was considering, and I don't know how, we are all academics we all have academic affiliations and backgrounds, and we do teaching. I don't know how any of this plays into education. So, Nisha's obviously doing a lot of work in education here, but what do we need to add to the curriculum? If you're teaching a storage course at CMU, does anything in AI need to show up there, or is that?
Well, I'm hearing from all of the corporate people, I don't need to do anything. So it's all good, right? Yeah. No, I'll say the biggest thing that comes to mind when you bring up the topic of AI in education is we have to tell people, and this also for the students in the room, right? There is still a path and a need for people doing systems and storage and stuff like that, right? Yeah, all we hear about now is AI ML everywhere. And I can tell you, at the university, we're now seeing that reflected in what the students believe they have to do in order to parlay going to the university into having a career, right? Whether it's master's students coming in after having CS degrees or it's undergraduates coming in after high school. I've had students who really love doing systems, feel like they have to ask, is it okay to do systems, or am I making a huge career mistake, right? There's you can't have plumbing that works without plumbers. Is kind of the way I describe it to people, and the infrastructure for doing large-scale AI ML is not going to It's going to be a while before we have the generative AI that's going to figure out how to make it for itself, right? Eventually, it'll move us all out of the loop, but I figure I'll be done by then. That's a problem for my kids and my kids' kids or something like that. But my bigger concern is that, actually. Like, there is a lot of effort to figure out what the AI curriculum looks like, and it's not the storage people they're going to ask about how to do it, right?
Right. I guess
it might be Nisha, but it's not like.
Well, so for folks in industry, if you're hiring a new undergrad or a new PhD student who's got a primarily systems background, is there AI-related stuff you think you'd prefer to see on their CV rather than just the traditional set of systems courses, or in addition?
I think the phrase there, AI literacy, is good. That's what I would look for. So myself, coming from a system background, I just feel there's a very big gap between even the terms and languages, like general software engineers talk about and AI people talk about. For myself, it took me a while to understand what is a feature store. Like, what is a feature? And what is forward pass, backward pass? I imagine the same as the other direction. So I think bridging this gap will be important in the curriculum.
Just to be clear, I was not arguing against that, right?
No.
I think that's going to happen. That's every student is going to want to have at least the basic understanding in their bag, right?
So if it helps any, I get questions from students doing AI PhDs, whether it's worth doing them, because they don't know if they can create an AI innovation that can keep up with OpenAI or Microsoft or Google, and it's a fair concern. You're off in your university, you're doing the project, you have access to a microscopic fraction of the resources that these companies have. How are you going to write a thesis that's going to keep up with the next 300 things they're going to deliver in the next year? So the only thing I can kind of think of, to be honest, I believe it's better to be in the applied fields than in the core AI field. And applied is systems, applied is medicine, because AI is a tool, and if you can wrap your brain around the tool and how powerful it is, you can do amazing things in your chosen discipline, whether it's systems or otherwise,
That's a great point. So in reading this title, I initially thought, well, I have nothing to offer here because I have never taken a computer science class in my life. I have a PhD in material science. My undergraduate's in ceramic engineering. There's no reason I should be on this stage at a computing conference talking about computing. But I've relied on the ability to reason and question things and figure things out, which isn't unique to computer science. These fundamental skills will serve students in any discipline. And so, AI literacy is critical from the standpoint of figure out where you can use it to improve your critical thinking skills. But do you need to take a class in AI in college to understand AI at any point in your future? I'm proof that the answer is no. You can figure it out,
right?
But you have to have the foundational skills to do that first.
And maybe this is like an evolution of, I think what's already been true over the last few years, right, is like graduating with like knowing C++ and object-oriented programming is fine, but having that mixed with material science or with biology or some other science that can then work together, and that's where like a lot of interesting papers end up, right, is combining these disciplines together. And maybe this is just sort of an evolution of that, I don't know, like at some level, and where you're injecting AI as part of that multidisciplinary work that we're going to be doing. You don't have to be an expert, but you have to be able to speak the language, as you're saying,
right,
so that you can communicate well.
You need to understand the science, and you need to understand enough of the AI that you can see the connection. And there's a lot of, because ultimately, look, there are so many problems that are unsolved, right? If we thought they were all solved, then we will have a problem, but we're nowhere close to that.
Well, it's good to know we're not going to run out of problems.
By the way, I am hearing that lots of college students are not able to get into the AI courses. They're full.
Oh, yeah.
Across the board. They can't get in.
Because all of the students believe that is the one true path now that has to be taken, right? Yeah. And by the way, the students aren't the only ones questioning whether or not they can be anywhere outside of a small handful of companies and do anything advanced in AI stuff, right? It's the faculty are freaking out,
Yeah.
right?
So I want to leave some time for questions. I don't know if there's any. I've tried to frame some questions. You've all sort of spoken about a lot of things. Are there other points in general that any of you were hoping to make that we haven't had a chance to elicit? Oh, dead silence. We've learned everything they've got to share.
Well, I feel like my parting thought is that I don't see a lot of problems that are unique to storage. There certainly are a lot of problems and open questions that AI brings, but I continually struggle to figure out what of those make good storage research problems. I think there are data research problems that are coming, but strictly in the context of storage, maybe the key is applying these broad AI problems in the context of storage.
I think the fast CFP always has a couple lines around data management and other data lifecycle stuff, and so we're not traditionally restricted to actually building storage systems. There's lots of other stuff that falls into the broad domain here. Maybe we should be leaning more into some of that.
Yeah.
Maybe you can rename fast to FAD, file and data.
And part of it is the shades of gray that Keith is bringing up, and then part of it is maybe reframing it from what stuff does storage have to do for AI to what stuff could it do that maybe helps. And maybe the answer is nothing, right? But maybe because the shades of gray are a thing, maybe some functionality shift to where the boundaries are can happen that makes it have a role to play to help reduce some of the trade-offs that have to happen in other parts of the system, right? And I don't know what the answer to that is, but it's not infeasible, right?
I mean, I guess my pioneering thought is that there isn't a ton of new things, but there is a lot of challenges to consuming and processing the data over the last year. That is not out of the box, go run by any stretch. So, and there is, it always goes back to that fundamental thing of our HPC for the last 20 years, right? Like, can you teach a physicist to optimize their code for storage? And the answer is no, probably. But nonetheless, we can't sit around waiting for I think the data scientists and everyone else, right, to optimize their code for our existing storage services. So how do we bring, and I don't think it's necessarily an education thing either, right? They still want their YAML file, and that's the entry point. So how do we just bring it and make it easy and simple and just really, finally getting, it doesn't have to necessarily be super smart, but it does have to sort of just work out of the box without 17, tell me your workload and I'll tune these 13 different things, and then maybe after 17 runs, we'll figure out how to make it efficient, right? So the more we can just do that sort of thing we've been doing with physicists for a long time, right? But now do it in maybe a more efficient and just accelerate the broad to all of these new people coming online.
I do think there's something significant to what you were talking about a long time ago in this panel of having a tool that helps the person that's trying to use the storage system in some intensive way to use it with a pattern that accommodates what it is they're trying to do, but also will perform well, right? There's only a relatively small number of patterns, right? Some of them are just always awful, but other ones, it depends on what it is you're trying to do, which one is the right one. And teaching people that don't live in that world how to make that decision for themselves, really hard, right? But somebody sitting next to that notices what you're doing and says, no, use this one of the scripts instead of that one of the scripts that somebody else wrote for you so you don't have to actually work it out, right? That's a doable thing.
Yeah.
And that's a storage research problem to figure out how to make that, right? That sort of automatically figures out which pattern they ought to be using and then allows them to hook that into their code so it's a minimal work, right?
I think there's a lot of opportunity in the data path, not in the control path, not in the data path.
Yeah.
There are so many problems. The problem is that they're hard to measure. They're a little hard to get your brain around, but they are absolutely critical and getting worse by the day.
Yeah, so my final comment is to add on to that. I think in particular, AI is so early that the way it uses storage is very inefficient and wasteful. Even in the simple kind of ChatGPT query kind of use cases, oftentimes you're loading the entire Shakespeare's collection in your GPU memory just to answer how to say hello in Spanish. So I think there's a lot to do just to deduplicate and do all the kind of stuff we discussed.
Love that.
Yeah.
Okay, well, seems like a good spot to wrap up at. I'd like to thank the panel, and then we can have some Q&A.